Hello student, in previous video we have discussed about the momentum, relation between the momentum and mass, momentum and velocity. Now momentum of object which is in a state of rest condition. So as we know that if any object it is in a rest condition, so their velocities become a zero. So as we know the formula of momentum P is equal to m into V. So V is equal to 0, then the P is also become a 0. So we can say that let's an object with a mass m, it is in a rest condition. Since the object is in a rest, therefore its velocity V is equal to 0. Now we know that the momentum is equal to mass into velocity. So the P is equal to m into V. But here as we know that the V is equal to 0. Why 0? Because the object is in a rest condition. So the velocity is become a 0. So the P is equal to m into 0. So if any things is up multiply with the 0, so it become a 0 only. So the P is equal to 0. Thus the momentum of an object in the rest, for example, non-moving is equal to the 0. Now let's talk about the uniform momentum. For uniform momentum, as we know that the SI unit of mass, it's a kg, means the kilogram. And the SI unit of velocity, it is a meter per second. So we know that the momentum P is equal to m into V. So the P is equal to the mass SI unit is a kg, and for the velocity SI unit is meter per second. So into meter per second. So the P is equal to the unit of momentum. So the P is equal to kgm divided by S, means the kilogram into meter per second. It is the unit of momentum. Unit of momentum as a unit of mass is equal to kg, means the kilogram. The SI unit of velocity, it is a meter per second. So we know that the momentum P is equal to m into V, means the P is equal to kg. Kg means kilogram, and V is equal to meter per second. So the P is equal to kgm into S, divided by S, means the kilogram meter per second. Now let's talk about the numerical problem which is based on the momentum. The first one, that the calculation of momentum. Example number 1. What will be the momentum of stone having a mass of 10 kilogram when it is throwing with a velocity of 2 meter per second? Here you can see there is two things is given. Two things are given. First one, that is mass, and the second one, that is of velocity. The mass of an object is a 10 kg, and the velocity of an object is a 2 meter per second. So note it down that the mass is equal to 10 kilogram and the velocity of an object is 2 meter per second. So we have to find out the momentum. As we know the formula of momentum, the momentum is equal to P is equal to m into V, means the mass into velocity. So the P is equal to 10 into 2, so it become a 20. So 20, and as we know the unit of momentum, kilogram meter per second. Thus the momentum of stone is equal to 20 kilogram meter per second. Now let's talk about the example number 2. Calculate the momentum of bullet of a 25 gram. Here the mass is given, that is of 25 gram, when it is fired from the gun with a velocity 100 meter per second, and the velocity is given V is equal to 100 meter per second. So first of all, whatever the things is given, that we have to mention. Here the velocity of bullet is given, it's 100. So write down 100 meter per second. Second thing, that is a mass is given, it is a 25 gram. So mention over here the mass of a bullet is equal to 25 gram. Now first of all we have to convert this gram into the kg, because as we know the unit of momentum is equal to kg into meter per second. So first of all we have to convert this gram into the kilogram. So 25 divided by 1000 kilogram. Why? Because the 1000 kilogram is equal to 1000 gram is equal to 1 kg. So we have to divide, so we get the kg. So the 25 divided by 1000, so it is a 0.025 kg. Now let's apply the formula of momentum. As we know, the formula of momentum is a is equal to m into v. The mass is a 0.025 and the v means the velocity, it is already given, it's 100. So the answer is 2.5 kilogram meter per second. The momentum of bullet is 2.5 kilogram meter per second. Now let's see the example number 3. Calculate the momentum of bullet having a mass of 25 gram is throwing using a velocity hand with a velocity of 0.1 meter per second. Now here the velocity is less from the previous example and the mass of a bullet is 25 gram only. So we can compare between these two examples, how the momentum is increase and decrease. Here the velocity of bullet is a 0.1 meter per second. The mass of the bullet is given 25 gram. So in previous example also we converted it into the kilogram. So in this also we have to convert. So the 25 divided by 1000 is equal to 0.025 kg. So the momentum is equal to mass into velocity. P is equal to m into v. So mass, as we know, it is a 0.025 and the velocity into zero point 0.1. So the P is equal to 0.0025 kg meter per second. So the momentum of the bullet 0.0025 kg meter per second. So by these two example you can conclude that how the speed or how the velocity is impact on the momentum. Now let's move further. Example number 4. The mass of a good lorry is a 4000 kg and the mass of a good loaded on its 20,000 kg. If the lorry is moving with a velocity 2 meter per second, then what will be its momentum? Here the velocity is given 2 meter per second and mass of lorry is given 4000 kilogram. And the mass of goods on the lorry is a 20,000 kg. So the total mass on the lorry it become a 4000 it's of lorry and the 20,000 it is of a goods. So it become a 24,000 kg. So as we have a formula of momentum is equal to mass into velocity. So the mass is equal to 24,000 and the velocity is become a 2 meter per second. So the momentum is become a sorry 48,000 kilogram meter per second. Let's see the next example. Example number 5. A car having a mass of 1000 kg is moving with a velocity 0.5 meter per second. What will be its momentum? The velocity of car it's a 0.5 meter per second. Mass of the car is 1000 kg. So the momentum P is equal to mass into velocity. P, as we know that P means that is momentum and the mass of the body is 1000 and the velocity it is a 0.5 meter per second. So it is a 500 kilogram meter per second. Till now all the things it is related to first law of motion. Now let's see about the statement of a second law of motion. So rate of the change of momentum of an object is proportional to the applied unbalanced force in the direction of the force. If I ask that write down the statement of second law of motion, then the rate of change of a momentum of an object is proportional to the applied unbalanced force in the direction of the force. Let's see, it's a mathematical expression. Suppose a mass of an object, it is a m kg and the initial velocity of an object is a u meter per second and the final velocity it is a v meter per second. So the initial momentum of object it become a p1 is equal to mu, u that is stand for the initial velocity, m for the mass of an object and the final momentum it become a p2 and for final velocity it is a v. So the final momentum p2 is equal to m into v. So let's talk about the change of the momentum. The change in the momentum is equal to the final momentum minus initial momentum. So we can say write down that the mv minus mv, mv minus mv. So here you can see the m is common, the mass of the object is common, so we can take it common. M is equal to m is common, so mv minus u. So the rate of a change of momentum is equal to change in momentum and divided by time taken. For the particular time, the change of momentum is how it is occurs. So that called the rate of a change of momentum. So it become a m v minus u divided by t. So the according to the second law, this rate of change in momentum is directly proportional to applied force in given time. So the F means the force is directly proportional to m into v minus u divided by t. And as we know that the v minus u divided by t is equal to a acceleration from the last chapter. So we know that the a is equal to v minus u divided by t from first equation of the motion. So the F is equal to k m f, where the k is the constant and which is assumed as a 1. So the F is equal to 1 into m into a. So F is equal to ma, where the m is equal to mass and the a, that is stand for the acceleration. So the SI unit is equal to kg meter per second or a Newton, you can say. The other unit is Newton. Force other unit is Newton. So the kg meter into second square, or you can also write down the Newton. Now let's talk about the 1 Newton. The 1 Newton means when an acceleration of a 1 meter per second square is seems in the body of a mass 1 kg, then we can say that the applied force on a body is a 1 Newton. 1 Newton is equal to when an acceleration of 1 meter per second square is seen in a body of a mass 1 kg, then the force applied on a body is said to be a 1 Newton. Now the how can we prove the Newton's first law of motion from the second law, that we will see in the next video. Thank you.